Let us look at Euclid's algorithm. General, what we have, G will be A comma B, right? Which is equal to G AX plus BY. Okay. So what we uh, that is which will be where you can solve look into the problem to find the GCD, right? So to find GCD of 54 and 7 and also express, okay, it in the form of 54x plus 7y. Okay, so let us see how we can solve this. So 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 54 can be written as 7 multiplied 7 plus 5. Okay, so which is 54. And as you can see here, uh, I I'll just rearrange this as 5 is equal to 54 minus 7 multiplied 7. Let us keep this equation 1. Now, as you can see, 7, right? Which is, as you can see, 7, which is greater than 5, right? So let us take 7. Okay, 7 can be written as 5 multiplied 1 plus 2, right? I'll rearrange this as 2 is equal to um, uh, 7 minus 5 into 1. Okay, let us keep this equation 2. Okay, as you can see here, 5, which is greater than 2, right? So, so, you can write 5, which can be uh, written as 2 multiplied 2 plus 1, right? So this will be 1 is equal to 5 comma 2 multiplied 2. Let us keep this equation 3. Okay, as you can see here, 1 is the last non-zero remainder. So as you can see, the GCD is 1. That is GCD of 54 comma 7 is 1. Okay, we have done the first part. Now using these 1, 2 and 3, let us get this in express in this form, 54x plus 7y. What is x and y here? Okay, we will continue by taking this last result. So let us see, write down that. Okay, so that's what. So taking 1 is equal to 5 minus 2 multiplied 2. Okay, now let us take the equation 2 using 2. So that is 2 can be written as 2 can be written as 7 minus 5 multiplied 1 into 2, right? That is using 2. Okay, I'm using 2 here. Okay, now let us try to multiply this. So this is 5 minus 7 multiplied 2. This is plus, okay, 5 multiplied 2, because 5 into 1 into 2, which is 2 again. So 5 multiplied 2. As you can see, this 1 times 5 and 2 times 5. So we can combine this together. 5 multiplied 3 is minus 7 multiplied 2, right? Okay, so I will take taking using 3. So 5 can be written as 54 um, minus 7 multiplied 7, right? Um, okay, so multiplied 3, right? Minus 7 multiplied 2. Okay, so I'll be using 1 here, using 1 I used here. So let us multiply this. So 54 multiplied 3, right? Minus 7 multiplied 21, right? Min minus 7 multiplied 2. Okay. So I should get in the form of 54x plus 7y. So 1 is equal to 54 multiplied 3, right? So 7, right? So 21 plus 2 gives me 23, right? 23. So if I write in this form, so 54 multiplied 3 plus 7 multiplied 20 minus 23. So 1 can be written as 54x plus 7y, where x is 3 and y is minus 2. So which is the required result. Now let us find the GCD of 385 and 792 and also express this in the form of 385x plus 792y. Okay, now as you can see here, 792 can be written in the form of 385 multiplied 2 plus 22, okay, or 22 can be written as 792 minus 385 multiplied 2. So let us keep this as 1. And as you can see here, 385 is greater number than 22. So let us keep 385 here. So 385 can be written as 22 multiplied 17 plus 11, or I can write this 11 as 385 minus uh, 22 plus 17. So keep this. And as you can see here, 11, if I 11 divides by 22 two times, okay, keeps the remainder 0. So you can consider 11 as the remainder, right? So the GCD will the GCD of 385 comma 792 will be 11. Okay, this is 11. So let us consider the equation 2. 11 is equal to 385 minus 222 multiplied 17. Okay. Again, let us consider this 22, that is the equation 1. Okay, let us substitute it. 385 minus, this is 792 minus 385 multiplied with 2. This is multiplied with 17. So 11 will be 385 minus 792 multiplied with 17 plus 385 multiplied with 34. So 2 multiplied 17 is 34. Okay, as you can see, this 395 multiplied with 1 and 385 multiplied with, sorry, 385 multiplied with 1 and 385 multiplied with 34. So I can combine this with this. So 11 is equal to uh, 35 multiplied with 385, right? And if I take plus, so 792 multiplied minus 17. So when you compare this with the given equation, you get x as 35 and y as minus 7. You see the working?